Annyeonghaseyo and welcome 8th graders. Welcome to Geology Lesson 10, Fossil Fuels. You'll notice that there is a change in our background. I am up in Bemidji now, trying to get some help with childcare because I'm losing my mind. Hopefully you also will enjoy the change of scenery. Let's go ahead and dive into our lesson. And for our entrance task, I just have a very simple question. What are fossil fuels? So go ahead, take a moment, pause the video, think about what you know about fossil fuels. Just write it down. Take, I don't know, maybe about 3 or 4 minutes, write 3 or 4 sentences about what fossil fuels are. And when you're ready to begin again, unpause the video and move on to our class objectives. So our objectives today are content. I understand how fossil fuels are formed and how carbon is cycled through the environment. Language objective. I understand how fossil fuels disrupt the carbon cycle. Now we have our keywords, which are carboniferous. And let me back up. Carboniferous is the name of a time period in Earth's history. It was after the Permian era. If you remember when I showed you that fossil of the gigantic dragonfly with like the 70 centimeter wingspan, that was from the Carboniferous period. Organic refers to any type of molecule or compound related to life. Organic compounds always have carbon within them. Limestone is a type of stone. It's a type of rock that's created from living things in the ocean. Usually it's things like coral, but limestone can also be made from different types of shelled animals that basically pull carbon, calcium carbonate, out of the water and use it to build their shells. Our next word is decompose. Decompose is when a living thing basically decays and changes into dirt, soil, that kind of thing. Non-renewable. Non-renewable means that once you use it up, it cannot be used again. It's non-renewable. And our last word is carbon cycle. Carbon cycle describes the process in which carbon is either released into the air or taken from the air and held in the earth. Okay, let's go ahead and begin our lesson. We're going to start by talking about the Carboniferous period. Since we're talking about fossil fuels, the Carboniferous period is the starting point for most of the fossil fuels that exist on Earth today. Now, during the Carboniferous period, this is what the Earth looked like. We can see that Pangaea is kind of smashing into Gondwanaland, but the supercontinent of Pangaea had not completely formed. At this point in time, Earth was dominated by giant forests that were in swampy areas. As I mentioned before, the percentage of oxygen in the atmosphere was extremely high. It was like 35%, and so you also had gigantic arthropods, like giant millipedes crawling around on the swampy forest floor. You had dragonflies as big as your arm. So anyways, this was a very different time period, and even the plants were quite different. The plants developed bark that was like 3 or 4 times as thick as tree bark it is today. And at that time, there were not a lot of bacteria or fungi that could really do a good job of decomposing these plants. Also, because these trees were located predominantly in very swampy forests, when trees would fall, they would get buried under the water. In the water itself, there wasn't enough oxygen to really break down and decompose those trees. And then so what you ended up having was sort of these piles of organic materials building up in swampy areas. And these piles of organic materials had sediments deposited on them, and after millions of years, what you end up with is sedimentary rock called coal. So these bullet points basically sort of repeat the information that I just gave you. So not only did organic matter convert into a sedimentary rock called coal, but also converted into a liquid known as oil and a gas known as natural gas. So coal is just a black substance that's essentially almost all carbon. I mean, it's basically made from undecayed organic matter that's compressed and transforms into a sedimentary rock. There are two types of coal, and what we're looking at is called anthracite coal, which is kind of more compressed. And there's also another type of coal called bituminous coal. I'm not sure if I'm pronouncing that correctly, but anyways, it's a more common form of coal. It's a little bit oily, it's a little bit greasy, it hasn't been compressed as much, and it doesn't burn as clean as anthracite coal. However, it is much more abundant than anthracite coal. Next, we've got oil, which I said is the liquid form of undecayed organic matter formed by the Earth's heat and pressure. And lastly, we have and this is a picture of crude oil, just this thick sort of black stuff, and we take crude oil and then we transform it into lots of other products like gasoline. We can transform it into jet fuel. We can transform it into diesel fuel for trains. Oil is also transformed into various petroleum products like plastics. Our plastics come from oil. And then the final fossil fuel that we have is natural gas, and this is sort of the gaseous form of undecayed organic matter that's created by Earth's intense heat and pressure. And natural gas is something that not everyone, but a lot of people have in their homes. If you've seen a stove that has these kinds of blue flames, these stoves burn natural gas. Okay, now let's talk a little bit about how we get these fossil fuels, because this is really an important topic, and the way we extract these fossil fuels is a very dangerous and destructive process. So first of all, we have coal mining. Now, traditionally coal mining was done underground because that's where we find coal, and you had to dig deep underground. It was very dangerous. A lot of times, because you have these tunnels, sometimes the tunnels would collapse, sometimes the miners would get trapped, sometimes there would be areas of the tunnels that would run out of oxygen and miners would suffocate. So it was just really, really dangerous. And so the solution to some of these problems that people had with mining was to just simply blow the tops of mountains off. So there's now a mining practice called mountaintop removal mining, which is happening all along the eastern United States. And basically they use dynamite to blow off the tops of mountains. They haul away the rubble with gigantic dump trucks, and then they mine the coal until they mine all the coal, and then once they do that, they blow off more of the mountain and they mine successive layers of coal that way. This is very destructive. It exposes all kinds of toxins and heavy metals to the environment. Also, it ends up creating gigantic sludge pools. And I'm not sure exactly, and basically I guess once you get all this coal dust, you get rain, and then you get sludge pools, which are extremely toxic. And so these sludge pools kind of hold the runoff waste from the coal mines, and occasionally these sludge pools they break, they flood an area, they poison all local wildlife, they poison people that live in the area. So mountaintop removal mining is extremely bad for the environment, and it's extremely bad for the miners, and extremely bad for anyone who lives in that area. For a long time, mountaintop removal mining was, I don't want to say banned, but let's say it was limited. But Donald Trump has sort of loosened restrictions on mountaintop removal mining, and that's something that's happening with renewed vigor in the United States. So coal mining is one form of fossil fuel extraction. We also have oil extraction, and usually that's through drilling for oil. You can see very large, how do I describe them? They almost look like sawhorses. They go back and forth back and forth, up and down. I'll have an image for you later, but anyways, you mine for oil that way, over land. When you are mining for oil over the ocean, you create these gigantic oil rigs. You can see in the background of this PowerPoint, that's an image of the oil rig called the Deepwater Horizon, and that there was an explosion, there was a massive oil spill, there was a massive fire, and to this day, wildlife in the Gulf of Mexico where this happened, so down south by Louisiana, what other states are down there? Texas, that whole area was devastated. The fishing industries there were devastated by this oil extraction disaster. And then finally we have something called fracking. Fracking is a way that they are extracting natural gas from the earth, and basically it involves drilling holes into the ground, and you basically drill a hole vertically into the ground and then you drill it horizontally so it's sort of parallel with the surface of the ground, and then you force water and chemicals into that hole, which creates fissures in the rock, and those fissures release natural gas, and then they extract the natural gas and sell it. So fracking is it's a more recent mining practice, and apparently it's extremely loud and also very bad for the environment as well. So fossil fuels, just in general to summarize, are terrible for the environment. However, our entire society, our entire world, our entire technology is dependent on fossil fuels. So 63% of US electrical plants use fossil fuels. Here we have an image of a coal-fired electrical plant, and I would say out of that 63% of electrical plants that use fossil fuels, most of them are coal-fired plants. Most of them are coal-burning plants, which releases tons of carbon dioxide into the atmosphere. In addition to that, almost all transportation in the United States uses fossil fuels. So cars, trucks, they use fossil fuels. And so when you drive your car, or even like, for example, Amazon ships something to you, fossil fuels are being used in the transportation of that thing that you're buying. Even when you go to the store, you buy vegetables, most of them come from Mexico. They got to get transported to the United States, uses fossil fuels. Trains use fossil fuels, boats, airplanes, any form of transportation primarily uses fossil fuels. These days we have some electric cars, but those electric cars are powered by electricity made from coal-burning power plants. So it's really hard to break free from this sort of cycle of fossil fuels. In addition to transportation and electricity, fossil fuels are used in plastics. Any plastic that you have is made from oil that gets refined and sort of recreated into different products. So plastics are made from fossil fuels. And lastly, asphalt for roads, airports, sidewalks, trails, around the lakes. That's all fossil fuels. And one other thing that I want to note about fossil fuels is fossil fuels are a non-renewable resource. This means once we use them up, then we don't have any more. It takes millions of years for fossil fuels to form, and so there's no way for us to replace or replenish the fossil fuels that we take from the earth. In addition to the problems with extracting and using fossil fuels, there's another problem, and it's related to our carbon cycle. Now carbon, it goes into the air and it gets sort of captured and stored in the earth through lots of different processes. So let's just go ahead and talk about these different processes. So carbon goes into the earth via limestone. So we have living creatures which build shells and build their bodies out of calcium carbonate, which has carbon in it, in the ocean water. And then those animals die and they become a sedimentary rock called limestone. So limestone sort of captures and sequesters carbon in the earth. Organic matter, like anything that's alive, uses carbon to sort of build its body. So that's another way that carbon is taken out of the air and sort of stored and captured inside of living things. Next, we have subduction. Subduction happens when, as you know, there is a convergent boundary and one plate goes under another. And so when subduction is happening, you have all this matter, typically from like an ocean floor, as a ocean plate subducts under a continental plate. So all that organic matter that's on the ocean floor is going into the mantle, and most of that is being captured and held in the mantle. We also have processes which release carbon into the air. And so decomposition, when a living thing dies, its body gets broken down into, I guess, more simple compounds. We basically get eaten by bacteria and fungus and so on and so forth. We turn back into dirt, and in that process, a lot of the carbon that was stored in our body is released into the air as carbon dioxide. In addition, some carbon is released in the air through volcanoes and volcanic activity. There have been several, I guess, dramatic incidences of climate change that were caused by volcanoes releasing lots of carbon dioxide into the air. And finally, fires are another way that carbon dioxide gets released into the air. As you remember, there were tremendous forest fires that happened in Australia and Brazil. I want to say last fall and summer. And so these events release a lot of carbon into the air. So there you have it. Hopefully by the end of this lesson you can understand how carbon is captured and stored in the earth or released into the air. And there's like a fine balance between these processes. During the Carboniferous period, as I mentioned, we had this tremendous growth of plants, but we didn't have a lot of decomposition of these plants. And so what ended up happening was these plants captured so much carbon from the air, they eventually changed the climate of the earth. There was I wouldn't call it a mass extinction event, but it was a big disruption of Earth's climate that happened because of the Carboniferous period. Towards the end of the Carboniferous period, there was so much less carbon dioxide in the air. The temperature on Earth decreased significantly. Glaciers began to form, they began to expand, and because of that, there were lots of living things that died or underwent dramatic changes. And so conversely, now what we're doing is we are taking all of that carbon that was trapped and stored during the Carboniferous period, we're burning it, we're putting it in the air, and so we're adding so much carbon into the air, we are again changing the Earth's climate. We're making the Earth warmer, and that's having some dramatic effects on us to this day. So hopefully you can understand just very roughly what the carbon cycle is, and also I hope you can understand fossil fuels better. If you have any questions, feel free to hit me up, sjkwok@sejongacademy.org. Also, feel free to contact Mr. OHOH1@sejongacademy.org, and I have office hours every morning, 9:30 to 10:30 a.m. Thanks. Peace.